So today we shall discuss the last lab experiment, the company database. So we have already discussed this company database as part of our theory topics. The same example has been provided as part of the lab experiment also. In the company database, the following tables are present: employee, in that SSN, name, address, sex, salary, super SSN, department number, and the department table, department number, department name, manager SSN, manager start date. So in department location, D number and uh, D location, project table, P number, project name, location, and department number, works on, SSN, project number, and hours. So in the respective tables, the attributes which are underlined are the primary keys. So in employee table, SSN, department number, D location, both D number and D location are the key. Then in project table, P number works on SSN and P number. So before creating the table, we must look at the queries, and it is based on the queries we will be inserting the values. Okay, so first query, make a list of all project numbers for projects that involve an employee whose last name is Scott, either as a worker or as a manager. So employee last name is given over here, Scott. So we have to insert an employee with this particular last name and show the resulting salaries if every employee working in IoT project is given 10% rise. So which means we have to insert a project with the name IoT. Find the sum of salaries of all employees of accounts department. Okay, as well as maximum salary, minimum salary, and average salary, which means we have to insert a department whose name is accounts. Then retrieve the name of each employee who works on all projects controlled by department number 5. So again, the data that is given over here is we should insert a department whose number is 5. Then for each department that has more than 5 employees, retrieve the department number and the number of its employees who are making more than 6 lakhs. So we have to insert 5 more than 5 employees for any one of the department, and within that some employees should have more than 6 lakhs. So these are the conditions based on which we have to insert the data. So look at the entity relationship diagram over here. So employee, its attributes is given. So there is a relationship from one employee to another employee, that is the supervisor, and employee with department. So it is the manager's relationship, and the relationship will have an attribute, that is the manager start date, and each department controls the specific number of projects. An employee works on a project and the attribute is hours. Okay, so which means an employee can work on multiple projects for different hours. So then look at the schema diagram. So in this particular schema diagram, SSN is the primary key, then all the attributes. So super SSN is referring to SSN of the same employee table. So department number, D name, manager SSN. So manager SSN is referring to SSN of the employee table. Then here department number of employees referring to department number, department location, uh, it is referring to department table. Then from project table also we have a links to department number. From works on we have a link to employee table as well as P number. So these arrow marks will give us a hint of the foreign keys. So first table creation, that is the department table. So we are creating the department table first. So create table department, department number, varchar of 20, primary key, department name, varchar of 20, manager start date, its data type is date. And once this command is executed and when we describe this department, so this is the description. But here manager start date we have not yet mentioned it as a super key. So if you observe the department table and the employee table, there is a cyclic dependency, that is a cyclic foreign keys. So where manager SSN will be referring to employee table, whereas in employee department number is referring to department table. So these two tables are mutually referring one another. So what we do is when we create the first table, we are not creating that particular attribute. So MGR SSN. So here MGR SSN attribute is missing, and that foreign key we will add later once employee table is created. So next in create employee table, SSN, first name, last name, address, then character 1, then salary, then super SSN. So super SSN references employee SSN. So which means it is referring to same table. Then department number references department of D number. So this relationship is entered. So once department and employee tables are created, then we will alter the department table to add a foreign key. So that is using a command, that is alter table department add mgr ssn references employee of ssn. So this command is executed. So why we are adding this particular attribute at the end is because there is a cyclic dependency. If while creating the department table itself, if we specify this as a foreign key, then we will lead to an error because the employee table has not yet been created. Or if we create the employee table first, then this D number foreign key we cannot add because department has not yet been created. So whenever there is a cyclic foreign key references, we create one table first without a foreign key, then we will create the second table with foreign key, then for the first table we will add the foreign key. So this is the description of employee table. Then create table, department location, department number, references department of number, then department location, varchar of 2, then primary key is both department number and department location. So here is a screenshot of this particular table. Then project table, create table project, P number, integer, primary key. So if for any attribute, if any single attribute is a primary key, then we will write the primary key keyword here itself. Otherwise, if there are multiple attributes that are acting as a primary key, then we have to put them together at the end. So project name, project location, and department number referring department table of department number. This is the description of the project table. Then works on table. So create table works on SSN, references employee SSN, P number references project P number, hours number of 2, then primary key SSN and P number. So this is one way of referring to foreign key. So another way is at the end, first we'll create the attribute and then at the end of this create command we'll add the foreign key command. So when we describe the works on table, so this is the table which we get. So two primary keys are available, that is 1 and 2. Now the insert table commands. So insert into employee values. So 101 John Scott is the second last name, then followed by the other details. Okay, while inserting the employee values, if you observe the last two attributes, so the last two attributes is the manager SSN and the department number. So we are passing null values. So once we create all the employees, we can then enter the manager SSN. Then at the same time, in order to enter the department number, so first we have to create the department table with values. So once we insert all the department values and employee values, then we can update these null values. So in the first step, we will specify MGRSSN and department number as null. So the other employee values are like this from 101 to 110. Okay. Then we will create three departments. So department 4, 5, 6. So 5 is asked in one of the query. So department number 5 should be there. So we are giving it as HR, and accounts department is asked in the query. So one of the department names is accounts. So now we can specify the manager SSNs also. So 101 as a manager for accounts department, 102 for HR department, and 103 for security department. So once the department tuples are created, then if we print the table, so this is how it gets printed. So once the department and the employee table values are inserted, then we can update the department number and the super SSN attributes of employee table using the update command. Okay. So since 101, 102, 103 employees are the managers, so we shall not create a super SSN for them because they themselves are the managers. So in order to update the values, the command we use is update employee set department number equal to 4, where SSN is equal to 101. And second one, department number 5, its manager is 102. Department number 6, its manager is 103. For rest all others, so we will be entering if it is department, if the department number of an employee is 4, we will set the super SSN to 101. If the department number is 5, we will set the super SSN to 102. If the department number is 6, we will set the super SSN to 103 because 103 is a manager of department 6, 102 is a manager of department number 5, and 101 is a manager of department number 4. And in the where condition, we will put the employee SSNs. So by executing these update commands, now if we look at the employee table, so you can observe the department numbers are updated over here along with super SSNs. But for these three employees, there is no super SSN because they happen to be manager of their own departments. So now let us insert into department location. So three departments. So only we are inserting a single value. 4 in Shumaga, 5 Sagar, 6 in Shumaga. So this is the department location. Then project project number, project name. So it is asked that there should be a project with IoT. So IoT location department number. So likewise, so for department number 4, we have added two projects. For department 5 also two projects, and for 6 also two projects has been added for each department. So then if we print the project table, so this is how it looks. So in order to print the table, the command that we use is select star from table name. Then works on. So the works on includes the SSN, project number, and number of hours. So for all the employees, we will put it. So this is how it looks. So employee is 101, works on project number 201 for 4 hours. Then 102, 203, 4 hours. So like that, we will insert the values for all the employees. So once we insert all the values, then we can have a look at the queries. So the first query, make a list of all project numbers for projects that involve an employee whose name is Scott, either as a worker or as a manager of that department. So we have to list all the project numbers where this person Scott is involved. So for this project, he can be a worker or he can be a manager of a department under which that project is there. So we will be using the union operator. So on one side of the union, we will put this particular thing. So where he is a manager, first part. So if that particular employee is a manager, then we have to join the department table, employee table, and project table. So the conditions to join the employee and department table include E dot department number is equal to D dot department number, and department number D dot department number is equal to P dot department number, and he has to be a manager. So D dot manager assistant is equal to E dot manager assistant, and finally we'll put the name condition, that is the last name should be Scott. So now it will return the um, project number of a department for which this Scott is manager. And secondly, as a worker. So in order to check uh, him as a worker, so we can directly put the condition on a works on table. So in the works on table, we will have the SSN and project number. So now in order to extract the project number, so we can link it with project table as well as employee table. So in order to link that, so it is here project table is P1. So P1 dot P number is equal to W dot P number. So then these two tables get joined. Then um, employee table E1. So E1 dot SSN is equal to W dot SSN. And finally the condition E1 dot L name is equal to Scott. So since the employee table and the project tables are involved two times in the same query, so the alias for each occurrence is different. So here it is P, this one it is P1. Here it is E, here it is E1. Okay. Then finally the two results will be joined together using the union operator. So in order to put the union operator, we must take care that the result of this select and here that should be same. So if both are same, then only we can apply the union operator, and which makes the result of these two queries as union compatible. So the result will be 201 and 202. So the second one, so show the resulting salaries if every employee working on IoT project is given a 10% rise. So in order to link the project name with the employee, we have to make use of works on table. So in our from class, we'll have employee, E works on, then project. So in order to join these three tables, so it is E dot SSN is equal to W dot SSN, W dot P number is equal to P dot P number, and P dot name is equal to IoT. Here that condition IoT we have put, that is the project name should be IoT. And all the employees salary is increased by 10%. So the employee details that we want is employee SSN, employee first name. In place of salary, so we have put a equation that is 1.1 into E dot salary. So 1.1 indicates it is the 10% increase in the salary. So the current salary is multiplied with 1.1. So that will give us the result. Here we are just displaying the increased salary, but we are not updating the salary in the underlying table. So and this particular expression is renamed as increased salary. INCR underscore salary. So in the result, so we have SSN, first name, increased salary. So 101, John, the salary is 7 lakh 70,000. So earlier in the insert command, his salary was 7 lakhs. And he is the only employee who is working on IoT project. The third query, find the sum of salaries of all the employees of accounts department as well as the maximum salary, minimum salary and average salary of the department. So here it is about the accounts department. So employee and department table should be joined together. Employee table with alias E, department table with alias D. So E dot D number is equal to D dot D number and department name should be accounts. So this is the condition. And what we need sum of the salary. So we can directly apply the aggregate functions. Sum E dot salary, max E dot salary, minimum E dot salary, and average E dot salary. So all the aggregate functions put together over here, and the result is displayed like this. So if you want, we can put an alias and rename the query result. So sum is this, maximum salary is 7 lakh, minimum salary is 3 lakh, and the average salary is 5 lakhs for accounts department. And the fourth query, it is retrieve the name of each employee who works on all projects controlled by department number 5. So here, first we must get the list of projects controlled by department number 5. That list we will get. Then we have to verify which employee works on all of those projects. So in order to solve these kind of queries, we have to use the um, set minus operation. So what we do is, if you observe here, in the first part, we will get all the projects of department number 5. So this query will return all the project numbers of department 5 minus the project numbers on which one employee works. So if you perform the minus operation, if the result is empty, so if the result is empty, it indicates this particular employee works on all all the projects of department number 5. If it is not empty, then it indicates on some projects of department 5 that employee is not working. So that is a set difference. So if it is empty, it indicates that particular employee is working on all the project numbers of department number 5. If it is not empty, it means he is not working on all or some of the projects of department number 5. So in order to solve this, we will use a correlated nested query where select SSN, F name, first name, last name, then from employee E where not exist, we will use not exist, because in the result, if the result is empty, then he is working on all the projects. If the result is not empty, that indicates he is not working on some of the projects. So that's why not exists is used on these kind of questions. Okay, and in order to solve these kind of queries, we have to use the minus operator. So first we have to this select statement will select all the project numbers of department number 5 minus the project numbers on which an employee is working. So select project number from works on where e dot ssn is equal to ssn. So e dot ssn means, so this is the attribute of the outer table. Okay, so outer table is e. So this ssn belongs to works on table. So this is a correlated nested query, and the only employee who is working on all the projects of department number 5 is 102, that is Raju. So for each department having more than 5 employees, retrieve the department number and the number of its employees who are making more than 6 lakhs. So first thing is that particular department should have more than 5 employees. So we have to first get those departments having more than 5 employees. So that we will be doing over here in the nested query. So what is this nested query doing? Select department number from employee group by department having count greater than 5. So this will select only those departments which are having more than 5 employees. Then in the outer query, our department number should be within this. So look at the query. So select department number, count of star. So department number, count of star indicates number of rows from department and employee table, where the department number of department table and the department number of employee table should be joined. So here the department and the employee tables are joined based on department number. And the condition here is employee salary should be greater than 6 lakh and department number should be in this one. So which means the in operator, it is a multi set. So department number should be inside this set. So what does this inside query returns? It returns only those department numbers which are having more than 5 employees. So then group by department number. So because we want a count on for each department, so we have to put group by department number. So this query is also having an inner query, but there is no correlation. So group by department number, and the result we'll get is department number is 5. 5 is the department which is having more than 5 employees, and 2 employees are taking more than 6,000 as the 6 lakhs as the salary. Okay, so this is the last query that is in this particular database. So this completes all the queries and all the 5 laboratory experiments. Okay, so I have already shared the commands for all the queries along with their executed screenshots. So you have to execute all these commands and check the results. So that's it. With this, we can conclude this laboratory session.